problem from the book is 9-8. An area in the XY plane is bounded by the curve y equals a, which is some constant, times x to the n. And the line x equals b. It doesn't really matter what n is, especially in the positive side, because if you think about what the graph of a parabola looks like, this is x squared. And if I wanted to know what x to the fourth looks like, it just goes up faster. And then when it comes down here, it gets a little flatter and it goes up faster. And the higher the value, the faster it goes up and the more square it becomes, the higher the exponent, as long as it's even. If it's odd, it's just going to have a similar shape on this side, but then on this side it just goes down. But we're not worried about the negative side. It will have a shape similar to a parabola if I look at just the positive side. We're going to just not worry about what n is at the moment. And then x equals b, that's where we want it to end. So we're really looking for the area from here to here, from here to here. And that's why it's telling me what's bounding it. Okay, we're looking for this area that's colored in here. And whenever I take the integral, I find the area under the curve to the x-axis. Or actually, I shouldn't say under the curve. I should say from whatever the curve is to the x-axis. Because if it was negative, it would still find the area from the curve to the x-axis. Okay. Determine the area by integration. Well, we know that this is y equals k x to the n. If I want to find the area of that, the area is going to be the integral, where this is dx, this is dx, the width of that, like our delta x, and the height is going to be our y value. We're going to come over here, and whatever the y value is going to be my y value. To find the area, I need the height, which is y, times the width, which we're calling dx. And for this problem, we're saying it is k x to the n dx. K is going to have to be a constant because we're just multiplying by some value. And when we're taking the integral, we can take the constant outside of the integral. So we can say this is the same as k times the integral of x to the n dx, where n is some exponent. We want to find an exact area. So we want what we call the definite integral, which is going to give me a number instead of just an equation. We're going to go, so our lower bound, because it's dx, we're looking at our x values. We're going to go from 0 to b. We don't know what b is, but that's where we're going. If I integrate this, our area is going to equal k times x to the n plus 1 over n plus 1. And we're going to evaluate this between 0 and b. That's what x is going to equal, some number between 0 and b. We can say this is k, and we can first plug in b. It would be b to the n plus 1 over n plus 1 minus 0 to a power. So we'll have 0 to the n plus 1 divided by n plus 1. Obviously, this is just 0. We get this whole thing equals k b to the n plus 1 over n plus 1. Determine the coordinates of the centroid G by integration with respect to x. Okay, so now I know we have a lot of centroid problems. I really want to go over this. Let's say you had a Frisbee. So there's my Frisbee. Pretend that's a Frisbee. And you wanted to just hold it on the tip of your finger. Well, as long as it's evenly distributed, as long as I found the exact center, I could balance it on one finger. This would be the center of mass, which is the same as the centroid. But we have all these weird shapes. It's not like we have a box or we have a square or we have a circle or we have a rectangle where we could just find the middle. Sometimes we have things that we can't find the middle of. For example, this particular problem has a graph that looks like that. And where is the center of mass? Who knows? So that's what we're going to find out with our centroid. It's basically the average. The formula we need to use is x bar. This is our x value for this. It's basically the average value of x. That's not an unusual notation, x bar, for the average value. And why I'm integrating is I'm going to take I'm taking little slivers and I'm going to find the center of that box. For example, if I had little slivers of each of those boxes, like we were doing on one of the worksheets, then it's a lot easier to find the center of this box. Maybe that one's here, and maybe this one's here, and so on. And if I add those all up and I divide by the total area, I get where the center of mass for just x is. That's why we use integration. Whenever we add a lot of little things together, we need integration. The formula I have is the integral of x times y of x dx divided by the integral of just y of x dx. Because this is the area. We're basically multiplying the weights of the x times the area divided by the area. I don't know if that makes sense, but that's basically what we're doing. This would be the same as the integral of x times, and my y of x is kx to the n dx divided by the integral of just kx to the n dx. And no, we can't just cancel. First thing I'm going to do is I'm going to find x bar. So I have x bar equals, and we're going to have the integral of k. K is a constant, so I can take it outside of the integral sign, and this would give me x to the n plus 1 dx. And I'm going to divide that by, again, I have that k, which I can take out of the integral, and this would be x to the n dx. Constants can cancel for sure. They're outside of that integral sign. So we integrate this and we get x to the n plus 2, because we add 1 when we integrate, divided by n plus 2 over, so this is the numerator of the numerator. Let's see, so that's x, yeah, that's right. So that's the integral of the numerator divided by, and this is x to the n plus 1 over n plus 1. And I can simplify this by saying this is x to the n plus 2 over n plus 2 times the reciprocal of the denominator, n plus 1 over x to the n plus 1. And if you know your exponent rules, This is the same as x to the n times x squared. This whole thing times n plus 1 divided by x to the n plus 1, so it's just times x to the 1 power over n plus 2. I can cancel this with this. I can cancel x squared with x, and I get x times n plus 1 over n plus 2. If I knew what n was and I knew what x was, I have the x value where my center is. Let's do y bar. Y bar is equal to the integral of, the way they have it written in the book, they have dA, which means the area. We're not going to do that. We're not using that formula because we're not doing double integrals in this class. I can say this is equal to, and I can take out that 1/2, and then I have y of x, and then dA, the area is going to be y of x dx. Remember, it's the height times the width. I get 1/2 times the integral of y squared dx. That's my numerator. And then I'm going to divide, just like I did before, by the area. I just divide by y of x dx. This whole thing is over y of x, the integral of y of x dx. And this is also over the integral of y of x dx. I have my x bar, I don't have my y bar. Let me rewrite y bar is equal to the integral of 1/2 y squared dx. And y of x we know is kx to the n. We're going to square that. Okay, y bar equals kx to the n squared dx times 1/2 divided by the integral of kx to the n dx. This is just the y. This equals 1/2 k squared x to the 2n dx divided by the integral. This one I can pull the k out, x to the n. This is equal to k squared over 2 times the integral of x to the 2n dx divided by k times the integral of x to the n dx. This k cancels with that k at the top. So I would just have k over 2 times the integral of x to the 2n is x to the 2n plus 1 divided by 2n plus 1. And the integral of x to the n is x to the n plus 1 over n plus 1. There's my numerator, there's my denominator, and that gives me k over 2 times, this would be 2n plus 1 over x to the n plus 1, and this is times n plus 1 over 2n plus 1. And we're going to simplify as much as we can. This is equal to k over 2. Now we have to simplify the x's. So this is really the same as x to the n squared, that's x to the 2n, times x, that's the plus 1, times n plus 1 And then this is x to the n times x times 2n plus 1. I can cancel this x with this x. I can cancel this squared with this whole, because this is really x to the n times x to the n. So I'm canceling one of the x to the n's. And I end up with k over 2 times x to the n times n plus 1 divided by 2n plus 1. This is actually my y bar. Because I don't know any values, I can't give you a number, but this is y bar. X bar is equal to, so now we have our x bar and our y bar. I would have x bar is equal to, I don't know what x is, it's x times, I know n is 1 2/3, so it'd be 2/3 x. And if I had numbers, I could put numbers in. Since I have no numbers, I cannot put numbers in. We know x bar equals 2/3 x, and y bar is going to equal k over 2 times x squared there times 2 over 2, n is 1, so that's 3. X, n is 1. So it's just x. Okay, the 2's cancel. I get k x over 3. We now found x bar and y bar.